Alright, so we worked our way down to the bottom now where we're talking about pipes or harmonics. This is a pretty easy one, really. You just have to remember that a closed pipe, the fundamental is a quarter of a wavelength. So you draw your node, and then we always have an antinode at the closed end. We get something that looks like this. L equals a quarter of a wavelength. Wavelength equals 4L. If the length is 0.15, we're just going to say 4 times 0.15 or 0.6, so 0.6 for the wavelength. Then, come on in. Never mind. Then we have to find the frequency. So frequency times wavelength is the velocity. It's a pipe, so we got to use 343, put in 0.16 for the wavelength, and we can solve for the frequency. So you got to take 343 divided by 0.6, you get 571 for the frequency. That's the noise that you would get when you blow over top of that length, 15 centimeters of a closed pipe. Do the same thing, but we're going to do it for 10 centimeters now because it's a third full. 10 centimeters is 0.1 meter. Still going to use L equals a quarter wavelength, right? Looks kind of like that. Or wavelength equals 4L. So we say 4 times 0.1 is 0.4, less tube, smaller wavelength. And we do 343 and divide by 0.4 instead. 857.5. Frequency's gone up. You know, if you fill up a bottle with water, you're going to get a higher pitch. Finally, have an open pipe. It's open on both ends, so it's kind of like a string in that sense, that it has nodes on the end. L equals half a wave, wavelength equals 2L. What we're going to do is we'll put in 0.15, so we get 0.3 for the wavelength, and we do 343 and divide by 0.3. And we get this huge frequency, 1143.3. And, you know, just to give you a sense of the kind of, see if I can, oh look, the negative looks like a positive in my computer. That is pretty sweet. But to give you a sense here of, can't quite get this to turn the way I want it. The noise that we're going to be getting, I'm going to go ahead and open up a program and play these sounds, just to give you some idea of what the heck these sounds would sound like. So I got the old AQT up here. Our first frequency was 571, and we jumped up to almost 900. And when we talk about 1,000, it's getting almost inaudible. Well, it's audible, but not very pleasant. But anyway, this explains different sounds for pipes. Alright. That's just too cool.